Hello everyone, welcome back to my channel. This is me Khushi and today we're going to be doing the 7th module of Python. So it's going to be really interesting. But before that, let me know that we are really close to 300 subscribers. So make sure that you've subscribed this channel and let's reach 300 very soon. So now let's just start with this. So this one is functional programming, which is very important module in Python tutorial. So you must watch this video. So functional programming is a style of programming as we see from the name and it's based around the functions. A key part of functional programming is higher order functions. We've seen this idea briefly in the previous lesson on functions as objects. If you haven't watched the previous lesson, you must go and watch it out. The higher order function take the functions as arguments and return them as the results. So we already go on like doing this. This is when you are actually printing a function or printing the things which are going on in a function. But functional programming is obviously important. The function applied twice in the example above takes another function as its argument and calls it twice inside its own body. So this is how you take functions as arguments and print them out. Now we have done with this one. So this is again an example. We have pure functions. Functional programming seeks us to use pure functions. Pure functions have no side effects and return a value that only depends on their arguments. For example, a pure function, now I'll give you an example which is not a pure function. Now, if I have an if and else statement, I'm using it inside a function, and I have a value of, let's say, x, which is not in that particular function. This function will not be pure. In the same case, if I'm using the if and else with a value of x, which is in the function itself, then the function will be pure because this function does not depend on any other function. Now here is a similar example. The value of x and y is in the function itself as an argument. The function above is not pure because it changed the state of some list. This is an impure function. As you can see, this is where the function starts and some list value is being changed, whereas this is a pure function because everything whose value is being changed, whose value remains the same, is inside the function itself, which means that the pure function does not depend on any other functions. Using pure functions has both advantages and disadvantages. Now let's look at the advantages. They are easier to reason about and test because everything is in the function itself, so you don't have to just move around. They are more efficient. Once a function has been evaluated for an input, the result can be stored and referred to the next time the function is used and the input is needed, reducing the number of times the function is called. This is called memoization. So that is actually a benefit because whenever the function has been actually stored, so whenever you need it, you can just refer to it. You don't need to again execute the function. It's easier to run in parallel. Now let us look at a disadvantage. The main disadvantage of the pure functions is that it is majorly very complicated and the otherwise simple task, since the appearance of inherently requires side effects. If you're going for pure functions, as we know that there is no side effects, but actually there must be side effects because it is better, and that is a disadvantage. This can also be more difficult in some situations. So it's very complicated when it comes to pure functions, and impure functions are a little bit simple to understand. Let us look at the next concept. Next, we have lambdas. I'm sorry if I'm pronouncing it wrong. So creating function normally using the def assigns it to a variable automatically. This is different from the creation of other objects such as strings or integers. Now, as you know, when we're creating functions, we use the def function and then we write some arguments, which are variables, so we actually assign them. But when it comes to some objects, strings, and integers, we don't do this, which can be created on fly without assigning them a variable. So the assignment of the variable is not important. The same is possible with functions. Now, if you want to do the same thing to functions, you can use the lambda syntax. Functions created this way are known as anonymous. The approach is most commonly used when passing a simple function as an argument to another function. As we have seen in the functional programming's first example, we use first function as a argument for the next one. So this is why we use the lambda syntax. The syntax is shown in the next example and consists of lambda keyword followed by the list of arguments. So as you can see, this is actually the function which we are using in the next function. So these functions are actually used as an argument for the next function. So this is better actually. The lambda functions get their name from the lambda calculus, which is a model of computation invented by Olzono Church. The lambda functions aren't powerful as named functions. They only can do things require a single expression, usually equivalent to a single line code. These are not better in cases when you have to write a very long function. These are only good when you have to make one function as an argument for the next one. So this is the only place where you can actually use them properly. These can have only a single line of code. So as you can see in the named function, you can use 3 or 4 or many lines of code. But whereas it comes to this anonymous ones, you can use only one line of code. In the code above, we created an anonymous function on the fly and called it with an argument. So fly in the sense without any argument. The lambda functions can be assigned to variables and used like normal functions as well. So this is how you assign them to variables, and you can use them as a normal function. You can use this as normal functions only when you have a single line of code. However, there are rarely a good reason to do this. It is usually better to define a function with def instead. So this is actually used in very less situations. Now next we have the map and filters. So the map is a built-in function which is map and filter, and they are really very useful for the higher order functions that operate on lists. For example, the iterables. The function map can take a function as an iterable as argument and return a new iterable with a function applied to each argument. This is actually a function map on how a function is going to work. So this is map add 5. This is as an example. We could have achieved the same result more easily using the lambda syntax because these ones are not really complicated. To convert the result in list, we use the list explicit. The function filters an iterable by removing items that do not match a predicate, where a function that returns a boolean, which means that it doesn't match a boolean. So filter is actually to make your function better. It removes the things which do not match in the whole thing. Like map, the result has to be explicitly converted to a list if you want to print it. So in map and filters, if you want to print anything, you have to convert them into lists. Now let us look at the next thing. Next, we have generators. So generators are a type of iterables like lists or tuples. Unlike lists, they do not allow indexing with arbitrary indices. As we know, the lists are indexed with 0, 1, 2, 3. So this does not allow in generators, but they can still be iterated through with the for loops. They can be created using functions and the yield statement. This is actually the yield statement. The yield statement is used to define a generator. Now, as we have seen in some other programming languages, the code is something and we use something else to define it. This is the same thing with generators. So wherever you see a yield word, you must understand that it is a generator. Replacing the return of a function to provide the result to its caller without destroying the local variables. So the yield is somewhat similar to the return, but the only difference is that it does not destroy the local variables, the variables which were already created. For example, here we have I as the variable. Due to the fact that they yield one item at a time, generators do not have memory restrictions. In fact, they can be infinite. So you don't have any memory restrictions in this. So this can actually go on. Now, for example, if we do the same thing with lists and stuffs, it is gonna be a problem because you cannot print infinite things in them. Whereas in a generator, you can. In short, generators allow you to declare a function that behaves like an iterator, and it can be used in for loops. Finite generators can be converted into lists by passing them as arguments. Using generators results in improved performance, which is a result of the lazy generation of values. So it is the result for the on-demand generation of values, which translates to lower memory usage. Furthermore, we do not need to wait until all the elements have been generated before we start to use them. So if you want to use the thing before the other elements are being generated, it is better to use these kind of generators. Next, we have the decorators. So let's see what they are. Now for the decorators. Decorators provide a way to modify functions using other functions. This is ideal when you do not need to extend functionality of functions that you don't want to modify. So decorators actually provide a way to modify some of the functions which you want. So here we have the example. Now we define a function named decor that has a single parameter, which is func. Inside decor, we define a nested function named wrap. The wrap function will print a func string that's called func and print another string. The decor function returns the wrap function as a result. We could say that the variable decorated is a decorated version of print text. It's print text plus something. In fact, we wrote the useful one. So it's actually kind of complicated. So the only thing is that for these kind of decorators, it provides you a way to modify the functions without using the other functions. So I'm sorry, with using the other functions. Now, if you want to modify the function, let's say 1, you can use function 2 to modify it. You don't need to extend it or remodify it in some other way. In our previous example, we decorated a function by replacing the variable containing the function with a wrapped version. The pattern can be used at any time to wrap any function with. Python provides support to wrap a function in decorator by prepending the function definition with a decorator name, that is the symbol. If we are defining a function, we can decorate it with a symbol. If you want to define a function which actually can be decorated, you can use the symbol. Next up, we have recursion. Recursion actually is repeating. So recursion is a very important concept in functional programming. The fundamental part of recursion is self-reference functions calling themselves. It is when you have the own function which is calling itself. It is used to solve problems that can be broken up into easier sub-problems of the same type. The classic, now this is actually something, we have a very lengthy problem, you break it into smaller parts and then bit by bit you just solve the problem. So this is what happened in recursion. The same function bit by bit is being solved or it's being executed. A classic example of function that is implemented recursively is the factorial function, which finds the product of all positive integers below a specified number. We actually use this. We actually have such things if you want to know all the positive integers products. Now, if I have the products of 3 or the products of 5 or something like this. So this is an example. Now here we have, generally this is the thing. Furthermore, one factorial of 1 is the base case, and it can be calculated without performing any more factorials. So this is an example for the recursion. The base case acts as an exit condition for the recursion. Recursive functions can be infinite, just like the infinite while loops. They often occur when you forget to implement the base case. Now, if you want to create an infinite function using recursion, you just need to forget the base case and you can just continue it. Recursion can also be indirect. One function can call a second and which calls the first, which calls the second, and so on. So you can actually make it indirect as well when the first is calling the second is calling the third, and goes on. This can occur with number of functions. So again, this can also be infinite. So yeah, guys, that is it for today's video. You will have to wait for the 7.2 of this lecture. So make sure that you have subscribed my channel, and let's reach 300 really, really soon.